Hello scientists, we are going to review for the Unit 5 test, and this is MNVA Physical Science, and I'm Miss R. There's a couple major things you need to remember about energy. It's never lost. It exists in several forms like chemical energy or mechanical energy. It changes forms. For instance, if I do this, or even if I just nod my head, I'm changing chemical energy in my cells into mechanical energy moving my head around. It's defined as the ability to do work. So energy is defined as the ability to do work. Let's test your knowledge. What's happening in this hand warmer here? In Minnesota, we use these often when we go outside on very cold days. We break them open, and all of a sudden, what was a cold package is now a nice warm hand warmer. What's going on with the energy there? Is heat entering the hand warmer from the air? Is stored energy being released? Is there an endothermic reaction happening? Endo means in. Exothermic would be heat is leaving, or both B and D. If you said stored energy is being released through a chemical reaction and it's exothermic, you're correct. What would happen if you grabbed this railing with your bare hand? Would heat leave your hand? Cold would enter your hand. Phase changes might occur, both A and C or both B and C. Heat would leave your hand. We don't talk about cold moving, we talk about heat moving in science. So heat would leave your hand and go to the railing. Phase changes might occur if you grab some snow. It might melt because the heat of your hand would enter the snow and make it into a liquid. So both A and C are correct. Would grabbing the railing be an endothermic reaction? I'll give you a hint. There's no chemical reaction going on if you're just doing a phase change or heat is leaving your hand and entering the railing. So no reaction. What happened to the average kinetic energy of the water molecules on this window here? You can see ice is forming on this window, which often happens here in Minnesota as condensation hits the window and then it gets cold enough to freeze. Generally, when there's a phase change and it goes from gas to liquid to solid, the molecules slow down. And we know that kinetic energy is the energy of movement. So if molecules are slowing down, we know that it decreased. The heat energy transferred to the window from the molecules, and they have less kinetic energy. They slowed down and became a solid. We already answered this one. What happened? Oh, we already answered that one too. Thermal equilibrium. So if heat energy is measured in calories, and calories are defined as the amount of heat energy needed to raise 1 gram of water 1 degree Celsius. If you drink some ice water, are you going to burn some extra calories? Let's think about it for a second. In the case of a 16-ounce glass of ice water, your body must raise the temperature of 473 grams of water from 0 to 37 degrees Celsius, your body temperature. In doing so, your body burns 17,508 calories. But the calories that we talk about when we look at the back of a package of, say, cookies are actually kilocalories. So when you think of those kind of calories in kilocalories, that's divided by 1,000, so that's only really 17 calories. What kind of heat transfer is going on here? Is it radiation, conduction, convection, insulation, or none? These people are hugging each other. And they're touching. Does that give you a hint? It's conduction because the molecules in the objects are touching. When two objects are touching, Like if I pick up this ball here and I grab it, that's conduction. I'm transferring heat through conduction. If you decide to lick the bowl when your mom makes a cake, what kind of energy transfer is going on here? Would it be chemical to electrical, chemical to mechanical, heat to chemical, chemical to light, or mechanical to light? If you're licking the bowl, you're moving your hands around, and so you are turning chemical energy in your cells to mechanical energy. And then you're putting some more chemical energy in your body, and it'll happen all over again because the cake batter has chemical energy in it. If you're going to drive this lovely vintage car and slam on the brakes, what kind of energy transformation would occur? What happens to brakes when you slam them? And would you want to go grab them? I don't think so, because brakes get pretty hot. That mechanical energy turns into heat energy in the brakes, and there are a lot of things in your car that manage that heat energy. If used in the heat transfer lab, this lovely quilt would it make a conductor of heat, or would it be a good insulator? And do insulators completely prevent the transfer of heat? Think about that for a second. It's going to slow the transfer of heat. Insulators are not good conductors. They do conduct a little bit. Quilts aren't great for like getting heat, don't take heat out of you as quickly as, say, grabbing a piece of metal or some water, but they do conduct heat a little bit. Kinetic and potential energy in pendulums. I have a pendulum here. When a pendulum's here, we know it has potential energy because it has potential to swing. When it's at the bottom of the swing here, and when it's moving here, when it's right there, when it's swinging, it has a lot of kinetic energy. It's moving. It's got a lot of energy of motion. The bob is the thing that swings on the pendulum, has the greatest potential when it's at the top of either side of the swing. At the bottom here, it has the most kinetic energy if it's moving through here. But the top on either side is where it has the most potential energy, because potential energy is the energy of position. It's the potential to have energy. Potential energy is stored in position. Think of like being at the top of the hill when you're riding your bike. You know you have the potential to build up a lot of kinetic energy if you're at the top of the hill. Kinetic energy is it stored in chemical bonds? Is it the energy of movement? Is it stored in the position of the object, or all of the above? We know that kinetic energy is the energy of movement. Potential energy, remember PO stands for position. So it's stored due to the position of an object. It's also stored in chemical bonds. Potential energy, if you have a candy bar just kind of sitting there in your locker or your cupboard, that's potential energy for you. You know, if you eat that, you will have energy. Your body can break down the sugar and make it into mechanical energy. Chemical energy is, of course, stored in chemical bonds. Falling objects have energy due to both the energy of movement and their position. So if you're halfway up the ski hill, you have some potential energy, but you also have a lot of kinetic energy. A pendulum has energy both in movement, because it's swinging, and potential, because it's going to have potential energy on either side at the top of its swing. how can you make a pendulum start at a certain angle go faster? So if we start a pendulum here, how could we make it go faster? Well, if I make the string shorter, and that's true if you have a metronome, an old school metronome. If you move the bob, a metronome is an upside down pendulum. If you move the bob all the way to the top, it's pretty slow. If you keep it down low, it goes quickly. So you want to decrease the length of the string. Hopefully you learned that from the lab. When I rub my hands together, they get hot. This is an example of what? I'm using mechanical energy and I'm changing it into heat energy. So energy is changing forms. When ice melts, the molecules move. You're going from a solid to a liquid. Think of a liquid as moving around more easily. So when molecules can move faster and more easily, the molecules are moving. Why? Kinetic theory. Here is the Wikipedia page on kinetic theory, and I wanted to show you this animation here because this is the temperature of an ideal gas, apparently, and we can see that these molecules, or these representative molecules, the little dots, are always moving. And as you heat them, as you add more heat energy and the temperature increases, they have more kinetic energy and they move more quickly. If you were to cool them, they would slow down until they turned into a liquid. They would always pool down here, and then eventually if you cooled them further, they'd turn into a solid. Is temperature the same as energy? Well, let's think about that. Temperature is a measure of the average kinetic energy of the molecules. So that's false. It's not the same, it's a measurement, an indirect measurement of the heat energy of a substance. So, temperature is an indirect measurement of the heat energy in a substance. Remember that one. It's an indirect measurement of the heat energy in a substance. Heat transferred by convection is caused by, not by touching something, because we know that's conduction. Radiators, that would be radiation, or actually conduction sometimes if you run into one. It's not insulation, it's not photons in the sun, that's radiation. It's moving liquids and gases. So moving air in your house or moving currents in the ocean, that is all heat transfer caused by convection, moving liquids and gases. Which type of energy can go through space? Well, conduction can't. Convection can't because those liquids and gases can't go through space. Radiation, it does not need solids, liquids, or gases to travel. It's energy that travels via waves, so it's infrared energy. In the elastic band lab here, we were testing the elasticity. And as the thickness of the rubber band increased, like here's a very thick rubber band, the rubber band did not stretch as much. The length of the rubber band, as you added more and more force, you added more and more mass here, and gravity pulled harder because there was more mass, and there was more weight and more force. The rubber band got longer and longer. The force needed to stretch an elastic object increases as the stretch is further. So the further you pull it, the harder it is to pull. In the ice cube part of the heat transfer lab, we did this in the simulation. We observed melting times to see which materials made good insulators, and we did that in the simulation as well. A thermos keeps liquids hot or cold by slowing heat transfer.